Hello, everyone. Just giving you an update. And gonna go over things. I'll keep the update quick, but my wife is doing well, but she still needs me to take care of her in a lot of different things, and so I'm not gonna be there today, obviously, potentially tomorrow, and then we're gonna kind of just see how the week's going. But she's already doing a lot better. It's been a long week, but hopefully I'll be back soon. And hopefully, I know last week there was a few that struggled with certain parts. I originally counted a lot of it as participation. However, for a lot of you that didn't do it, I now expect that after this video too, that you'll know how to do it. You can work with someone who's learned how to do it. But if you did it this week, I know that you all tried your best. But now hopefully I can help make sense of at least the 126 assignment, and I'm going to go over the 127 assignment. And then I'll talk about what today's assignment looks like. If you feel confident on the 126 and the 127, you can go ahead and start today's. Today's is going to count for accuracy. I did give you multiple attempts to check and try the this, but it is going to be for accuracy. And this will be kind of the end of division. You're going to see it again when we go into our next section, but I won't make you do it later in this week. I'll just have you do an assignment that's review on everything else. All right, so synthetic division. Now, synthetic division, I think, is a lot easier than actual division. It basically takes this long process with long division and it simplifies it. So I'll talk a bit about synthetic division, and if you kind of get it but you want to go over the assignment, you can kind of jump ahead a little bit. But I want to kind of review what synthetic division is before I start doing some practice problems. So synthetic division is just an alternate method used to divide a polynomial by a binomial of degree 1. You may find this to be a quicker, simpler method, and it is. It's much easier. Here are the steps. So if you want, you can write these down. I'll kind of talk through them, but it's a lot simpler than, like, this looks like a lot of wording, but it's a lot easier than you'd even expect. So after writing a polynomial in standard form, which is the same thing you did before, write the coefficients of the dividend if the dividend is missing a term. Use 0 as a placeholder. Now, we did that before with long division. We're going to do that same idea. It's important that you do that or else it won't divide properly. And then write the constant a of the divisor in a box. Bring the first coefficient down. I'll kind of explain what that means in a second, but you're going to bring the first coefficient down, and whatever makes x or minus a equals 0. We're going to go over that in a second. And then you're going to multiply the number just written in the box row by a and write the product under the next coefficient. Add the products and the coefficient above it. Repeat until you get to the last column, and then write the quotient. The numbers along the bottom row are the quotient, and the power of the first term is 1 less than the... I'm going to move my screen, but where I have the video, it's currently blocking some of this. But you'll be able to write this down. To me, the wording doesn't work or flow as well as just visualizing it. But basically, all we're going to do is multiply, add, multiply, add, multiply, add. So it makes it a lot easier. All right. So let's say you're given something like this, and I'm showing you how kind of the book lays it out. You want to find the way they talk about it right here is whatever makes it minus a. Remember, that's how they put it. But I like to think about it as whatever makes this 0. And the reason I did do that is because if you ever have a number in front, it would be, your a would actually be negative 2/3 if it was something like this, because you're not just like, the 3 is not just a factor, but the 2 as well. But don't worry about that right now, and even when we get into that, I just chose to use long division for those. I'm going to teach you how to do it, but you can use long division for those type of questions, but this is going to be a lot easier. So whatever makes your equation 0, you're going to put in like a little box in the top left corner, and then you're going to put all of your coefficients. So this was whatever was in front of each number in the equation that you were dividing. You're always going to bring the first one down, and then you're going to multiply, add, multiply, add, multiply, add. So here, add the product of the coefficient, and then keep repeating until you get to the last column. So here, they brought the first one down. They multiplied -3 and 3 and got -9. And then they added and got -11. Multiplied -3 and -11, got +33. And then added these two right here and got -20. Multiplied -3 and -20, and now they got 60. And now they're just going to add these two. And then they get 0. That is your remainder. So we love to see a remainder of 0. It makes it easy, but if it's not 0, you're going to do the same thing you did before, and we'll have some of those in our practice questions. So then lastly, you're just going to write the quotient, which should be, I can explain this better. I can't go back because I'll mess up the video. But we got 3, -11, 20, and 0. Now the last number is your remainder. So if it's 0, you don't have to worry about it. If it's a number, then you're going to put that divided by the equation you started with. But we don't have to worry about that. Now, the numbers remaining, it's always going to go in order from the next variable in the sequence. So originally it was x to the third, now it's x squared, x, and then your constant. It'll make sense when I go over the assignment, which I'm going to do now. So for the 126 assignment, a lot of you struggled with this because I know we're still confused on synthetic division, but I'm going to break it down, and I think it'll be a lot easier for you. Sorry, did that mess with the mic? So let's dive in. All right, so if you saw the first video, you know that when you have this -1, that just means you're dividing by this. Hey, bud. So it's going to basically look like this, because a negative exponent, think about it as like a positive exponent, you're multiplying by that many. A negative exponent, you're dividing by that many times. So if it's -1, you're just dividing by it once, which is all you'll see in this scenario. So all we have to worry about is dividing this, and the way we're going to do it with synthetic division is we're going to figure out what makes v minus 4 equal 0. So it's hopefully quite obvious, but if not, you can bring the 4 over and you get that it is 4, because 4 minus 4 equals 0. So we're going to put 4 in this little box. Now, I hope I didn't lose you by this point, but basically, whatever makes the thing you're dividing by equal to 0. So if this was plus 4, it would be minus 4. If it was minus 2, it would be positive 2. If it was plus 2, it would be negative 2. Whatever makes it 0. So in this case, it's 4. And now we're going to move all these numbers. We're going to line them up at the top. And now we're always going to carry down our first number. So 3 kind of comes down here, and it just hangs out, because whenever you divide, it's always going to be that number unless there's a fraction. But we're not really going to worry about that. So now we just play a game of multiply, add, multiply, add. So we're going to do 4 times 3, and we get 12. So now we're going to do -7 plus 12, and we get 5. And then we'll do 5 times 4, and we'll get 20. And then we'll do, and then we'll do -10 plus 20, and we get 10. So 10 is our remainder. Now we're going to write remainders the same way we did with long division. And then these are going to follow the sequence one less than what we originally started with. So we started with v squared, so it's going to start with just a v, and then this will be our constant. And then the way we write our remainder is whatever the number is divided by what we are originally trying to divide by. All right. Hopefully now that you've seen it that way, it's making it easier. Again, I'll go over even more questions like that with you. So hopefully after you see me do it quite a few times, it'll just click. Hello, I moved camera angles so that you can see Fozzie. He's just ominously in the background. In fact, maybe I'll go switch the light on. All right, so let's talk through this one. Again, we're dividing by t plus 4, and so whenever you have the negative exponent, really it looks something like this, or you can just think about it as that big polynomial divided by t plus 4. And we just want to see what makes t plus 4 equal 0. So it's going to be -4. So -4 makes t equal to 0. All right, so we're going to put -4 in our little box thing, and then we're just going to bring all the numbers down from the other polynomial. So 3, 4, -32, -5, and -20. So we just bring all that down, and then we're always going to bring the first one down, so 3. And then we're going to play a game of multiply, add, multiply, add, multiply, add. So -4 times 3 is -12. Then 4 minus 12 is going to be -8. Then -4 times -8 will be +32. And then -32 plus +32, or 32 minus 32, either way, it's 0. And then 0 times -4 is 0. -5 plus 0 is -5. negative 4 times negative 5 is positive 20. So negative 20 plus 20, we get a remainder of 0. It's always nice when we have a remainder of 0. And then this is going to follow in order from, we started with T4. If you look up at the equation, we started with T4. So it's always going to be the next in the sequence. So this is going to be T3, T2, so on and so forth. So it's going to look like this, but we can make that look even nicer because you don't need your 0t and you don't need your remainder when it's 0. So we can simplify this to just that. Nice and simple. Again, now that we've done a couple of these, I think once you do one or two more, you'll realize this is a lot easier than the regular way. I think it's just confusing the first few times you do it, but then it just starts to click. So let's try, maybe I'll have you take a second to try the next one, but I think it'll click. All right, so again, he just banged his head. Oh, Fozzie. He's wagging his tail, so he's fine. All right, so let's just think for a second. Remember, you want to think what c plus 2 equals 0. I'm going to go ahead and jump to that because I'm hoping that's like what's clicking. So what makes c plus 2 equal 0? Negative 2. Negative 2. So you're just going to put negative 2 in a box, and then you're going to bring all these numbers down. 3, 6, negative 2, 4, 3, 6, negative, oh my word. I was doing it so fast that I didn't even catch on to the fact that we're missing a gap right here. And this is where I think some of you are going to struggle if you're ever missing a gap in the sequence. So 4, 3, we should have a 2. So in its place, you always want to put a 0. And then negative 2 and 4. But yeah, if you're missing any number, put a 0 there. And like, because when you divide it, it could come out different if you forgot to put a 0 there as a placeholder. All right, and then the rest is the same way we've been doing it. Always bring your first one down, and then multiply, add. So in this case, 0. Multiply, 0. Add, 0. Multiply, 0. Add, negative 2. Multiply, 4. Add, 8. So, and then it's going to follow the sequence just one less. So here we have 4. So this will start with C3, and then C2, C by itself, and then constant. Those should be C's. I copied it probably from the one before, but didn't realize I didn't change them here. But they go away anyway. We can make this look a lot nicer by getting rid of these. And then all you're left with is 3c to the third minus 2 plus 8 over c plus 2. All right, so here we're dividing by m plus 4, so we just need to think, what makes that 0? And it's going to be negative 4. So negative 4 is going to go in our little half box, and then all of our constants. If it's just a letter by itself, remember there's basically an invisible 1 there. So it's going to be 1, 1, negative 6. We're always going to bring the first one down, and then we're going to multiply, add, multiply, add. So 1 times negative 4 is negative 4. And then 1 minus 4 is going to be negative 3. Negative 3 times negative 4 will be positive 12. And then 12 minus 6, or negative 6 plus 12, will be 6. And so remember, we started with m squared, so this is going to be m, and this is going to be our constant, and this is our remainder. Now, remember, with remainders, you're going to leave that in a fraction. So it's going to look like this. M minus 3 plus 6 divided by m plus 4. All right, so again, we are dividing by a minus 3, so we just need to think, what makes that 0? And it's going to be 3. And then we're going to bring all of our coefficients down. We'll first put 3 in the box, sorry. And then we're going to bring them down. So we start with 1, and then negative 6, 10, negative 3. And then you're always going to bring the first one down. Then you're going to multiply, so 3 times 1. Then add, negative 6 plus 3 gives us negative 3. Multiply, so 3 times negative 3 is negative 9. Add, we get 1. Multiply, so 3 times 1 is 3. And add, we have a nice remainder of 0. In the future, that is muy bueno. That is, like, we love to see that. And then we started with a to the third degree. This will start with a to the second, and then a, and then our constant. So our final answer is a squared minus 3a plus 1. All right. So here we're dividing by x minus 2. So we're just going to think, what makes that equal to 0? And if we plug in 2, it would make this 0. So 2 is going to be in our half box. And now we're just going to bring all of our coefficients down. So 2, negative 7, 7, negative 2. And then always bring the first one down. And then multiply. 2 times 2 is going to be 4. And add, negative 7 plus 4 is going to be negative 3. And then negative 3 times 2 will be negative 6. And then add, or just 7 minus 6 is 1. And then multiply. 1 times 2 is 2. And add, and again, we have a nice remainder of 0. Woo! So, we're going to kind of just put this in order. This will be our constant. This will be x. This will be x squared. So our final answer is 2x squared minus 3x plus 1. All right. So again, we have x plus 7, and we just want to think, what makes that 0? And it's going to be negative 7. So we're going to put that in like a little box. And then we're going to bring down all our coefficients. So we have 1, we have 2, negative 34, and 9. And always bring the first one down. And then we're just going to play a game of multiply. So just negative 7 times 1. And then add 2 plus negative 7, or 2 minus 7 is negative 5. And then multiply. Negative 7 times negative 5 is 35. 35 minus 34, or negative 34 plus 35 is 1. Negative 7 times 1 is negative 7. 9 minus 7, we have a remainder of 2. Remember, if you have a remainder, you're just going to leave that in a fraction with the number that you were originally dividing by. And then we're going to go, this will be our constant, this will be x, this will be x squared. So our final answer is x squared minus 5x plus 1 plus, 2 over x plus 7. Just looking at him. He wants me to throw it. I put it under the blanket that I had. So enjoy him destroying this while we also go over the question. Hopefully it's not more distracting than all the other things you distract yourselves with during class anyway. All right, so we want to find out what makes x plus 3 equal 0, and it's going to be -3. So we're going to put that in the little box area, and then we are going to bring down all of our coefficients. So 2, 10, and 17. We always bring the first one down, and then we're going to multiply. So -3 times 2 is -6, and add. 10 minus 6 is 4. Multiply. -3 times 4 is -12. And then add. 17 minus 12 gives us 5. So we're just going, remember, if we have a remainder, it's going to stay being divided by the number we're dividing by. This will be our constant, and this will be y. So our final answer is 2y plus 4 plus 5 divided by y plus 3. All right, so we now have p minus 2, and we want to see what makes that 0. So obviously it's going to be +2, and we're just going to put that in a little box area. Now we bring all of our coefficients down, so 2, -1, -10, and 8. And then we're always going to bring the first one down. So 2 will come down, and then we'll do 2 times 2, and we get 4. And then -1 plus 4, or 4 minus 1, will give us 3. And then we're going to do 2 times 3, and we get 6. And then -10 plus 6, or 6 minus 10, will be -4. And then 2 times -4 will be -8. 8 minus 8, we get a nice remainder of 0. Yeah. So our final answer will be 2p squared minus 3p minus 4. Hopefully by now it's become super easy. I know some of my students that are in my honors, they're a little ahead, and they find this really, they like doing this more than a lot of other things that they've had to do. Obviously it's not as fun because I'm not there, but this is actually pretty, once you get used to it, it's just like, oh yeah, of course. It's almost like a little game. So I'm hoping, I mean, he is loving it, clearly. So hopefully you're loving it too. All right. Okay, so this one looks scary. And if we were doing long division, it probably would be scary. But with synthetic division, this is going to be super easy. Again, we just want to see what makes x plus 2 equal 0, which we know is going to be -2. So we're going to put -2 in our little box thing. Bring all the coefficients down. 4, 18, 20, 10, 8. And then we're going to always bring the first one down. So 4 is going to stay 4. The only time you'll ever see that change is if we're using, if it's a fraction. But again, you can use long division in that case. All right, and then we're going to multiply -2 times 4, and we get -8, and add, or 18 minus 8, and you get 10. 10 times -2 is -20. 20 minus 20 will be 0. 0 times -2 is 0. 10 plus 0 is 10. 10 times -2 is -20. And that means -20 plus 8, or 8 minus 20, we get a remainder of -12. So we can kind of set this up already, but we can get rid of our 0 to save, like to simplify it a little bit more. So our final answer is 4x cubed plus 10x squared plus 10 minus 12 divided by x plus 2. Again, it looks crazy complicated, but it's pretty easy. The only thing that might be a little bit hard is if we had a fraction. Or if we had one that didn't work as well, which I'm actually going to show you now. So if you're dividing with a coefficient other than 1, let's see how the book does it. But basically, they divided, because this is a 2 right here, to set it up, they divided everything by 2, which is not is kind of how I do it, but I wouldn't do it at this step. So you can see from here to here, they divided everything by 2. So 4 divided by 2 is 2. 37 divided by 2, they kept that as a fraction. And then 4 divided by 2 is 2. 9 divided by 2, they kept that as a fraction. The 2 here goes away, and then this becomes 1/2. That's sort of how I do it. I just would probably do it before you do synthetic division. But either way, what makes this 0? Well, positive 1/2. So you're going to do synthetic division with positive 1/2. I'm just going to show you their work. I'm not going to make you do it, but you always bring the first one down. But notice, if you didn't change this to a fraction because it was 2x plus 1, this was originally 4, so you can't bring the 4 down. You need to make this a half, and then you're going to do a half times 2, you get 1, add 1, multiply by a half, you get a half, add, and this is 36 divided by 2, which gave them negative 18. And then negative 18 times a half is negative 9. 2 minus 9, negative 7. Negative 7 times a half is negative 7 over 2. This became 2 over 2, and then that's how they got 1 as a remainder. So here you have it. So I didn't give you any like that to solve, but I also would never leave it like this, and I don't think they do either. I think we have one more slide on this. So yeah, they change it to 2 divided by 2x minus 1. So I was going to say I'd keep it as whatever we started with, but you have to kind of multiply by what you took away at the start. So we divided by 2 at the start. So you then multiply the top by 2, because this fraction is the same as the 1 over x minus 1/2, if that makes sense. Or you can even think about it as, how do I get rid of this fraction? And you have to multiply by 2. In the case of fractions, whatever you do at the bottom, you have to do at the top for it to stay the same. And so that's how they got here. Anyway, you can use that method if you'd like, but I'll show you. I'm going to start to dive into the 127, and I tended to use long division to show you how to do this, so to avoid more confusion with synthetic division. But that was 126. I know a lot of you struggled with that because I didn't have a video going over it. I just had so much going on. It was crazy. Luckily, I've had a bit more time now. Again, it's still been really, really busy on my end. But I've been trying to be understanding on your end, although I mean, if you're watching this, then you're doing everything right. But some people, I know I'm not there, but I think I've said this to some people before. It's you are the one responsible for learning math this year. I'm just the one trying to help you do it. And unfortunately, I'm not there, which does stink. But it's still you that has to do all this. I can't do it for you, or just because I'm not there doesn't mean you're not going to do it or not going to learn. I'm just there to help you learn. Anyway, let's dive into 127. All right, so 127. If you did all your assignments last week like you're supposed to, or if you did, you are you're excused from this, or I'll count it as extra credit, basically. Some of you already got extra credit for trying this, but for those that did not do the work last week, I am now having you do this work as well, and it will be counted as a grade. It is a little harder than the last one, and the other tricky part is some of these questions towards the end, I did about two times. Basically, they can change quite a bit, or there's different versions of those questions. Now, I did at least two versions. I don't know how many there are. I just kind of went in and found two different versions, and they're all very similar. So if you follow how to do it, you'll be able to do yours. But I am therefore potentially making you do some work on your own. But also for those that were curious, I'd love you to watch this, and I'll kind of go over how to do some of these trickier ones. So let's go ahead and dive in. So you can divide this whichever way you are enjoying the most. However, I said in the earlier part of this video, I'm not going to be relying on synthetic division when it comes to things that won't easily equal to 0 or give you a fraction. So like right here, we'd have to divide by 2 on to everything to get rid of this, and we'd end up having to multiply everything by half. So I'm actually going to use long division for this example, and for a lot of the first couple I use long division. So we want to think, how many times does 2x to the third, or 2x go into 6x to the third? How many times does 2x go into 6x to the third? And you can even think about it as 6 divided by 2, or what times 2x would make it 6x to the third, and then x to the third divided by x, or however you want to look at it. There's a couple ways to look at this part, but either way, you should get that it's 3x squared. So then we consider, if we're multiplying 2x by 3x squared to make it close to 6x to the third, then we also need to multiply that to the 1. So this basically needs to multiply to both of them. And we get 6x to the third plus 3x squared. And now you subtract. We subtract. And these should always cancel out. And then x squared minus 3x squared will be negative 2x squared. Now, again, we need to think 2x goes into 2x squared how many times? Well, first we have to make it negative, so it's going to be negative, and then we just need one more x, so it's going to be negative x. Oh, by the way, if you're confused how we got this, we brought it down. On some of them, I think on the next ones I brought the arrows into it, but we brought this x down. So negative x times 2x plus 1 gives us negative 2x squared minus x. And so we're going to subtract these, and these cancel out. And then this is a minus minus. This is one of those weird things where we're going to end up adding these. And so we get 2x. And then, oh, there's an arrow. And then we bring the 0 down. Now you'll notice the original equation didn't have a 0. You always want to have something as the placeholder if something's missing. You want to have a 0 as a placeholder. And then what do we need to multiply 2x to make it 2x? 1. And then 1 times 1 is also 1. So that's how we get this. And then we're going to subtract, and we get a remainder of -1. Now, just like earlier and earlier in the week, whenever you have a remainder, you're going to leave it in a fraction with what you were originally dividing by. So there you have -1. I just moved the negative to the front. But basically, 2x to the third plus x squared plus x divided by 2x plus 1 is 3x squared minus x plus 1 minus, this should just be minus, sorry, ignore him, minus 1 divided by 2x plus 1. All right, so this one looks complicated, but it's actually really easy. So Jada used long division to divide these, and this is her work. So we're trying to find A, B, and C. Well, A is super easy because that was just whatever she brought down from the original equation, which we can see right there is x squared. So super easy start. Now, to find out what our B is, we need to consider that at this step, they did 3x times x plus 2 to get whatever they got right here. So they did 3x times x plus 2, and they got 3x squared plus b. Well, let's look at this. So 3x times x, that gave us 3x squared. 3x times 2, that gives us 6x. So b is 6x. And then our c is super easy. It's our remainder. We don't even have to put that in the fraction. We just need to figure out what was left when it comes to the numbers. And so all we have to look at is 1 minus 10, and we get -9. And that is our A, B, and C. This one is slightly more complicated, but it's still doable. You just have to think a little bit. So I guess to start it off, yes, we can fill in these missing pieces. And that's because we have this information right here, basically, because we know 3x times whatever was right here would give us 9x squared plus 3. And so we need to think, what times 3x gave us 9x squared plus 3x? Which I guess you can do a little bit of dividing on your own, or you might can think 9x squared divided by 3x, that would be 3x, and then 3x divided by 3x is 1. So to fill in that gap would be 3x plus 1. He's just being a little weirdo. He does this all the time, just standing around the corner like a weirdo. He's currently under my desk. Anyway, all right. So we want to find out what's in this missing box right here. And I know that we start with x squared. It's going to be something x plus something, a constant. And we can see right here that they brought a 5 down. So that must be something x plus 5, right? Ooh. All right, so now we need to consider what's happening right here. And So something x minus 3x is giving us negative 3x. Well, that, if we think about it, is just 0x. So right in here would be 0x plus 5. So very doable. Ooh. All right, so Tomo and Jamal were dividing this number by x minus 3, and one claims that it's negative 100, and Jamal claims that the remainder is 26. Let's see who's right. Let's go ahead and divide it. You could have used synthetic division here if you wanted, but I went ahead and just used long division. So we're going to go ahead and see how many times x goes into 2x to the third power, and it goes into it 2x squared amount of times, because 2x squared times x would give you 2x to the third. But we also have to consider what negative 3 times 2x squared will be, which is negative 6x squared. So now we subtract this to find out what's left, and we get, because it's minus minus, you end up adding the 6. So I know there's some confusion, but minus minus, you add the 6. So this becomes 2x squared, and then we brought this 3x down. Now let's go ahead. How many times does x go into 2x squared? I'd say 2x amount of times, because 2x times x would give you 2x squared. And then negative 3 times 2x will give you negative 6x. And then we're going to do we're going to subtract, and we're going to do minus minus, which is plus, so we get 9. And then we bring the negative 1 down. And then how many times does x go into 9x? Well, 9 amount of times. So we do 9 times x, which is 9x, and then 9 times negative 3, which is negative 27. So then we subtract, minus minus makes it plus. 27 plus 1, or minus 1, gives you 26. So our remainder was 26. So when we look back at the question, it was Jamal who was right. And that's because Tomo divided by x plus 3. What a silly little guy. And then Jamal, he was right on it. He divided by what he was supposed to. All right. So now let's look at this one. Because we have a number in front right here, I'm going to use long division, but if you get used to using the fractions for synthetic, you can. But we just have to think, how many times does 2v go into 8v4? Well, we'd need 3 v's on top of this one to make it 4, and we need to do 2 times 4, so 2v3. 4v3, because 4 times 2 is 8, and v3 times v will give you v4. 4v3 times negative 1 gives you negative 4v3, and then we're just going to subtract these two. And so these cancel out. They should always cancel out. The minus minus makes it plus. So now we're looking at positive 4v3. And then we're going to bring this 0 down. Now, the reason there's zeros here in the first place was, remember, we went from 4, and then we are missing a 3 and a 2. And then this is considered 1 and 0. And we want it to make sure it's in sequential order. So then how many times does 2v go into 4v3? Well, we need 2 more v's, so it's going to be v squared. And to get 2 to 4, we'd multiply 2. So 2v squared. 2v squared times 2v gives you 4v3. 2v squared times negative 1, though, gives you negative 2v squared. Remember, though, we're going to subtract these, so the minus minus makes it plus. So we get 2v squared, and then we're going to bring our negative 7v down. How many times does 2v go into 2v squared? Well, we got the 2's lined up. We just need this v. We just need 2 v's, so we need one more. So we're just going to do plus v. Now v times -1 will give you negative v. And then we're going to subtract these. The minus makes us plus. So -7 plus 1, or 1 minus 7 gives you -6v plus 5. How many times does 2v go into -6v? Well, we have v's, so we're good. We just need to consider how many times 2 goes into -6, and we'd multiply -3. So if we multiply -3 by 2v, we get -6v, and then -1 times -3 is +3. And then we're going to subtract these. 5 minus 3 gives us 2. So our remainder is 2. And remember, when you have a remainder, you're just going to keep it in the fraction. So it'll be -2 divided by 2v minus 1. All right, so 8v to the power of 4 minus 7v plus 5 divided by 2v minus 1 should give you 4v to the third plus 2v squared plus v minus 3 minus 2 divided by 2v minus 1. Whoa, we're almost done with the long division ones. All right, so same idea here. You could do synthetic, but you'd have to do some you'd have a fraction, so I just thought it'd be easier to do long division. We had to think, how many times does 3x go into 3x5? Well, we have 3's, so that's perfect. We just need 4 more x's, so x to the 4th. So now we have to consider 3x times x to the 4th will give you 3x 5. But x to the 4th times 1 will give you x to the 4th. And we're going to subtract. These cancel out. 7 minus 1 gives you 6. And then we're going to bring this 2x3 down. So 6x4 plus 2x3. Now, how many times does 3x go into 6x4? Well, the 3, it's going to be 2 times. And then the x, we need 3 more x's. So 2x3. So 2x3 times 3x gives us 6x4. 2x3 times 1 gives us 2x3. Now we're going to subtract these. These cancel out, and then these actually end up canceling out. And then we carry the -3x squared down. Now, how many times does 3x go into 0? Well, a 0 amount of times. So 0 times 3x will be 0. 0 times 1 will be 0. So we just kind of move down to our -3x squared, and then we bring down the minus x. So how many times does 3x plus 1, or 3x, go into -x squared? Well, we have 2 3's, but one's negative, so we need a negative. And then we have one more x, so -x. Or minus x. Now -x times 3x would give us -3x squared, which is what we want. And then -x times 1 would be -x. And then we subtract these. Remember, or these cancel out, and then these actually cancel out. So we get 0x. And then we bring the -6 down. Now, realistically, what you're doing here is -6 divided by this number. And then that is your remainder. Like, this happens to be the last bit. So our remainder is -6. So we're going to put that in the fraction with what it was originally being divided by. Sorry, this was supposed to represent that we're dividing by that. All right. So this one, it looks a little different, but it's the same idea. We're just going to divide 2a plus 1 divided by the number on top. So how many times does 2a go into 12a3? Well, 12 divided by 2 would be 6, and then you need 2 more a's, so 6a squared. Now 6a squared times 2a, that would have been 12a to the third, which is what we want. But then 6a squared times 1 would be 6a squared. So now we're going to subtract this, and we get -2 minus 6 gives you -8, and then we brought this 14 down. And whoops, I spoiled it, but 2a goes into -8a squared, -4a amount of times, because you need one more a, and then 2 times -4 is what gives you -8. And then -4a times 1 gives you -4a. And then we're going to subtract these, and then these cancel out, and then the minus makes us plus, so we get -10. And then we bring the 5 down, and then we have, how many times does 2a go into -10a? Well, we have 1a for both, which is great. And then how many times does 2 go into -10? I'd say -5 amount of times. -5 times 2a is -10, and -5 times 1 is -5. We then subtract those, and then these cancel out, these cancel out. We get a nice remainder of 0. And so 12a to the third minus 2a squared minus 14a minus 5 divided by 2a plus 1 is 6a squared plus minus 4a minus 5. All right. I believe this is the last long division one. All right. How many times does 3x go into 3x to the third? Well, x squared amount of times. X squared times 3x is 3x to the third, which is perfect. And then x squared times 2, x squared times 2 gives us 2x squared. And then we're going to subtract these. -4 minus 2 is -6, and then we bring the 5 down. And then how many times does 3 go into -6? X squared, well, we need one more x. And then negative and 2, 3 times 2. So -2x. Now -2x times 3x gives us -6x squared, which is what we want. And then -2x times 2 gives us -4x. Then we're going to subtract. Remember, when you subtract, the minus makes this plus. So 5, these cancel out, and then 5 plus 4 gives you 9x. And then we bring this other 4 down. How many times does 3x go into 9x? Well, they both have an x. 3 goes into 9 3 times. So 3 times 3x is 9x. 3 times 2 gives us 6. And then we're going to subtract that, and we get -2 is our remainder. So remember, the remainder, you're just going to divide it by what you were originally dividing by. So when we divide these two, we get this. Woo! All right, finally back to synthetic division. So think about what makes 2t minus 2 equal 0. Well, 2, obviously. This is one of those questions that yours might look different. I'm going to do 2 different versions of this one, and then we'll move to the next one, do 2 different versions, and so on and so forth. All right, so we're going to put 2 right here, and then we're going to bring all of our constants down. So 1, -6, and 8. Now, we always bring the first number down, and then we're going to multiply, add, multiply, add, multiply, add. So 2 times 1 is 2. -6 plus 2, or 2 minus 6, gives you -4. 2 times -4 is -8, and this gives us a nice remainder of 0. So this is just t minus 4. That's a really nice one. So for number 9, you might have this version, or you could have a completely other version. But again, the same idea is here. What makes h minus 4 equal 0? 4. So we're going to put 4 in our little box, and we're going to bring all the constants down. So 1, -2, and -8. We're always going to bring the first number down. Then 4 times 1 is 4. 4 minus 2 is 2. 4 times 2, that gives us 8. 8 minus 8 gives us 0. So this one has a nice remainder as well. So this one is h plus 2. All right, so now this one could be different versions you might have for number 10. Same idea as the last couple. What makes t minus 4 equal 0? Well, 4. So we're going to put 4 in our little box and bring down our constants. So we have 1, -7, and 14. Now, we're always going to bring the first number down, and then 4 times 1 is 4. 4 minus 7 is -3. 4 times -3 is -12. And then 14 minus 12 gives us 2. So we have a remainder of 2. So that's what's different about this one versus the last one. And remember, the way you write remainders, you're going to put it right back as though it was a fraction, or what was left, but as a fraction. So this will still be your t, and this will be your constant, but this will be in a fraction, like this. All right, let's try another one just like that. All right, so here we have h minus 1, and we want to find out what makes that 0, and it's 1. So we're going to do 1, and we're going to synthetically divide it with the first equation. So we're going to move our constants down, 1, -5, and 5. Always bring the first number down. And then 1 times 1 is 1. 1 minus 5 is -4. 1 times -4 is -4. 5 minus 4, you get a remainder of 1. So this one, similar to the last one, this will be our constant, and this will be our h, and then this is our remainder, so we'll stay in a fraction with those numbers. All right, so this one is a slightly new one. You might have a couple different versions of this depending on what you have, but they all kind of work out the same. So again, we're going to see what makes x minus 5 equal 0, and it's 5. And then this is the kicker for this one. Remember, you need to fill in zeros if you're missing pieces. So we're missing x squared, we're missing just x. All we have is x to the third and a constant. So we're going to put zeros in their place. So we're always going to bring the first one down. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. 0 plus 25 is 25. 5 times 25 is 125, which means we have a remainder of 0. And then this last one is our constant. This one's going to be x, and this one's going to be x squared. So probably different, very different if you forgot your zeros. That's why the zeros are important. All right, same idea, but different numbers. So what makes x plus 6 equal 0? Well, it's going to be -6. So we're going to put that in our box, and then our constants are 1, and then don't forget your zeros, 0, 0, 2, 16. We're always going to bring our first number down, 1. 1 times -6, -6. 0 plus -6, -6. -6 times -6 is positive 36. 0 plus 36 is 36. -6 times 36 is -216. -216 plus 216, or 216 minus 216, either way you get 0. So our final answer is x squared minus 6x plus 36. Whoa. All right, there's going to be 2 for this one, but this is going to be our last one for this. So what makes x plus 3 equal 0? It's going to be -3. So we'll put -3 in the box and bring our constants, our coefficients down, which is 1, 4, and 4. Now we always bring the first number down. 1 times -3 is -3. 4 minus 3 gives us 1. -3 times 1 is -3. And then 4 minus 3 gives us 1. It's nice to get all ones, but we do have a remainder. So this will be our constant. This will be our x. And then the last one will be our remainder. So we're going to keep that as though it's in a fraction. So we get x plus 1 plus 1 divided by x plus 3. All right, last one. So what makes x minus 4 equal 0? Well, it's going to be plus 4 or positive 4. So we're going to put that in the box, and then we're going to bring our constants down, 1, -2, and 5. We're going to bring the 1 down, and then 1 times 4 is 4. 4 minus 2 is 2, or -2 plus 4. And then 4 times 2 is 8. 5 plus 8 gives us 12, or 13. Whoops, 13. I caught myself before the click. But that's going to be our remainder. So we have x plus 2 plus 13 divided by x minus 4. All right, let me know if you have questions on the 127 assignment. As far as the 130 and 131 assignment goes, this is going to be kind of it's a higher grade than the others. I think I'm counting it as a half quiz grade because I counted the other one as a half quiz grade. But you have multiple attempts, you have multiple tries. You can work together. You can use any of the notes or the videos. Just try your best on this assignment. This is the last time I'll quiz you on this, because later in the week I want to do a refresher on all of polynomials, and then we'll start a new topic next week. But I won't put division in those. I'll just go back to the other pieces. But I hope this video helped you guys. I tried to make it a lot faster towards the end. I hope you're all doing well. Feel free to reach out if you have questions, and hopefully see you soon. All right. Thank you. Bye.